Hi, welcome to this new video where I will show you the dynamic partition pruning feature in Apache Spark 3.0. In the screen you can see right now the definition of the datasets I will work on in the demos. So you see that I have one very big table with 5,000 rows and two smaller tables with 820 rows. So I'm creating then with a partitioning column for the number. Just to keep it simple, I will prefix all columns with the table name so that I can immediately see during the debugging for what dataset given column corresponds, which is not obvious in the cases illustrated here, which will be the joins. So as you can see, I'm defining the partition number from some auto-incremented number, and at the end I'm computing the statistics for the columns. In the first example, I will show you what happens when the dynamic partition pruning is enabled and what happens when it's disabled. So let me run this code in the debug mode. And as you can see in the example, I'm doing a sample join between the bigger table and the smaller one and filtering the smaller table on its ID column, which is not the partitioning column, as you remember, and it should produce the dynamic partition pruning, so reuse the broadcast exchange as a subquery filtering condition on the bigger table. And that's the first intervention of the DDDP, which is retrieval, or rather the check whether the columns used in the join condition are the columns used in the partitioning schema. And as you can see here, I am checking whether this column is defined as the partitioning column, which is obviously true. And here I'm verifying whether it's worthy to apply the partitioning pruning, which, as you can see, it's true. And that's the new node which is inserted. So as you can see that we are inserting an extra predicate to the left side of the join. And this extra predicate will take the right side of the join in the filter condition. So that's the filtering plan that will be referenced here in this logical node. And that's the part which is responsible for the physical execution physical planning of the dynamic partitioning pruning. And as you can see, you retrieve here three scenarios I listed, I presented in the article, which is linked in the description of this video. And in this first scenario, you can see that we are issue a broadcast exchange reuse with this subquery broadcast exec node that will be wrapped by dynamic pruning expression. So let's see now what happens when this optimization is disabled. Maybe before I will show you what was the plan that was printed, and as you can see, you retrieve here the subquery broadcast with the reused exchange, which is nothing more, nothing less than this query execution. Let's see now what happens when the same query is executed without the dynamic partition pruning. And as you can see in the execution, the breakpoints weren't reached. And you can see that also in the proposed plan, that is nothing more than a broadcast hash join. So I will just put it to true like it was before. So in my third example, I will show you that the exchange will not be reused, but the optimization will still apply because it's more efficient than performing the join. So the executing the subquery will be more efficient than performing the join. So let me run the code, and we retrieve here our usual verifications on the partition columns used in the join condition, and you can see that the execution flow is the same. And unlike in the previous case, you can see that here we are in the third use case where we cannot reuse the exchange because we configured Spark session like that, and also that the partition pruning can be used not only with the broadcast mode, so with the broadcast exchange. And you can see that for this last specific case, we will create a sample subquery with the filtering plan on the smaller table. And you will see that on the physical plan. As you can see, we have this smaller table here, and we have the bigger one just here. And as you can see in the plan, it executes a subquery being exactly the same thing like this block. Yeah, and that's for the third case. Let's see now what happens for the second case, where, as you see here, the dynamic pruning expression will be a sample true literal, which means that when it will evaluate, it will immediately return true, so it will not perform any filtering action or any real filtering action on the data. It may happen when the ratio computed in this method between the partition between the two sides of the plan is not beneficial for performing this subquery execution. So you can see that I disabled the flag for the broadcast, and that, unlike in my previous examples, I'm joining here the small table with the very big table, and I'm performing the filtering condition on the side of this very big table, which will make this condition false. And let me show you that. And we are here on the usual check on the partition columns used in the join condition. And now let's see the result of this equation, which will be false. And you can see that the has benefit flag is set to false, which means, and you will see that just after that, during the physical planning, we will fall in this second case, which will add a dummy condition on the dynamic pruning expression node. And to see that, let's analyze the plan. And you can see here that we retrieve our dummy expression that obviously will do nothing on the data. And before I terminate, I will show you what happens when we are using two columns which are not the partitioning columns in the join condition. So I will add an extra breakpoint here to see whether this getPartitionTable method, checking whether the column is the partition column, will return something or nothing. And as you can see, for the small table, we retrieve nothing. So the part scan is known. And the same applies on the very big table. And because of that, because as you can see, the part scan is the first condition of the if case clause, we are not going into this expression. We are not generating whether the pruning is beneficial, and we are not inserting the predicate. That's the reason the plan will remain the same as the initial one. And as you can see here, it's a sample broadcast hash join. And that's generally very basic, very high level examples of the dynamic partition pruning. And if you want to discover more about this feature, more internal details, and also understand maybe better how does it work under the hood, I invite you to the article which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.